And hello, and welcome to Database Design Chat number 10. Tonight, we're going to talk a little bit about a topic that can be complicated, and that's performance. Because to a lot of people, performance is the primary thing. I lost a person in a pre-con once. I mean, it could be coincidental, but when I came out and said, performance is not the most important thing. In fact, it's one of the least important things to your database design. He just left. And, I was getting to the point. I've recently learned to start out a little softer than that, but I was getting to the point where to note that it's super duper important, right? But it's not the most important thing because I harp on this a lot. Correctness is the most important thing. So, get going. Again, I'm Lewis Davidson, Linktree/DRSQL. That's where you can find all my information, personal, non-personal, etc. And fast is really relative. Are we trying to do something that a race car would do? Or are we trying to do something that a 18-wheel truck would do, a tractor trailer would do? Are we trying to do something that, it really makes a tremendous difference what your target is? I have a small NUC Intel machine, and it's really nice. I also have a little Mac Mini, not as fast in some respects as the Nook, but I'm trying to run lots of big queries on the Nook. So I've sort of separated them out to different tasks. But I could also go out and spend $4,000, $5,000, $6,000, $20,000 on a computer and do the same things with it. So we want to size our performance, our needs to what we're actually trying to accomplish. If you're not trying to ride around an oval 200 miles an hour or do a road race 200 miles an hour or anything 200 miles an hour, you don't need a car that'll take you that fast. I mean, you may want one. I'm not saying it's not cool to have a really fast computer, a really fast car, but it's unnecessary. And when we're talking business things, necessary is really important to the discussion. So we get down to what is fast enough. How do you know when your things are fast enough? I mean, I tried to think if there was a way that software running too fast is a problem. There's only a couple of things I thought about. One is if it's presenting things faster than the person can intake them, right? I mean, if you played video games on a computer back in the old days, they were matched up to the computer speed. And when you bought your new computer and your faster computer, it didn't emulate anything. It just ran really fast. And so you could get by, you could cheat, you could, do all sorts of things. We had a turbo button back in the old days. But that's, people gotten smarter about that. Now they adjust based on the speed of the computer, and usually it'll be graphics are better or worse based on how fast the computer is working. So if I'm writing a query and I say select star from table, if I get back that result in 1 minute or 2 seconds, there's not any real downside to me getting it back in 2 seconds unless I've done something that will cause it to no longer be correct. I can, in SQL Server, we have this no lock or read uncommitted isolation level. And that can be negative. If we needed to be blocked to wait for someone to do something, that's acceptable performance lag, right? As long as it's running as fast as it can, that's great. Ideally, you have some sort of service level agreement with your customer to say, I need this to perform this particular amount of good, fast, right? My customer sitting at their computer, they're typing things out, they're writing queries while they're on the line with the customer. If it takes more than 3 seconds on average, then it's a problem. Okay. So you have that written down. You have ways to test that. You are keeping up with whether that's fast enough. And if it's not fast enough, that it's time to do something about it. We'll talk a little bit about what you can do about performance when we get into it, but we're not going to go so deep into performance tuning today. We're just going to talk about what, makes something adequately fast. And this whole idea of performance not being the most important thing is because it's a balance. We have on the one hand cost. Like I said, I can buy a $20,000 computer to sit on this desk to run terminal services most of the day. And I can also run this $700 Mac Mini, get the same value out of it, right? There's a cost, but I also may be trying to run 500 terminal services and run terabytes of data through a SQL Server. I can't do that on the Mac. I'd have to do it on the PC, and I may not be able to do it reasonably unless I have a much more robust computer than I have. Obviously, do we need to be faster? Correctness. I don't want to cheat and end up making things worse than if I just had to wait a little longer. And then there's this one that I really don't love always, but abilities. If your programmers don't know what they're doing, they don't understand how things work. Maybe you can't do it any better than adding hardware, right? That's another balance altogether. We'll talk about in a minute. But we want to get to the point where we're getting the performance that we need. So let's think about this for a second. What if we go into our system and we realize we can tune this thing? So we have 100 employees processing 1,000 transactions per day. Nice round numbers to make this math easy. Each transaction takes 10 seconds. So this is a million seconds per day. We divide that by 60, we get 16,000 minutes. We divide that by 60, we get 277 hours. Okay, now if we go in and we cut that down to 5 seconds a transaction, we're saving 134 hours, 38 hours of waiting every single day. Maybe I spent $10 million to make this happen. Maybe I added an index, right? What you did really tells me whether this is a value. So the real question comes, what are they doing with that time? So if the customer is sitting there and they're waiting on the screen to refresh, like they sit down, they type, look up customer, and 10 seconds later it comes back, and all you're getting is, okay, give me just a second. This is going to take about 10 seconds. Okay. Or they go, wait a minute, give me your name, and bam, now it's 5 seconds or 2 seconds or something less. That's a big win because now you've increased their throughput. They're going to be able to take more calls. They're going to be able to do more stuff. And that's what we're after. So there's more of the next level resource, the person, the machine that's processing, that has to do some check before it moves on to the next thing. Those kind of things are fantastic. Now, if this is stuff done in the background, I type in my query, and part of my script is to get to know the customer and ask them some things about themselves and say hello, right? That 10 seconds is nothing. 10 seconds goes by, fast. So you don't have to worry about it then. Then it's of less value. So if you've spent a lot of money on making that query faster and you didn't actually need to make it faster because it doesn't really help anything, it doesn't hurt that it goes faster, but it doesn't help that it goes faster. So what you had to do to get there is important. Keep in mind that sometimes it can be that people cost a certain amount, and then upgrading the equipment costs more than that is worth. And it may be okay that the employee, you're going to hire more employees and it's going to be okay as well. It's really important to know that it's not just about computer programming when you're building things. It's nice to do a good job. It's nice to find these ways to make things go faster. But if you end up spending more money than it's worth, you haven't really done very much. All right, so general performance. General performance. Is that how I mentioned mother joke? It's okay. correctness is always number one. If you don't get the answer right, it's of no value. There's some easy wins we can have when doing performance tuning. Indexing is generally a performance win. I add indexes, it's going to hurt performance some, but generally they're way more valuable to add to performance. Because if you're doing queries and you're having to scan an entire table and you can only look up two or three rows in the table to get to the answer with an index, obviously that's a big win. Doesn't have to change the code. Nothing changes whatsoever. Um, you know, reconfiguring your hardware, understanding maybe you don't have enough RAM or you have slow disks or things like that. That's also an easy win. I mean, it's more difficult than things like indexes, but it's an easy win because all you got to do is change something in the background and it works. Somewhat less easy is code changes. If you don't change the public interface of a stored procedure or a query and you make some changes and make it a little faster, that's easy-ish, but it's still a little bit more complicated. I mean, it's cheaper than new hardware, obviously, but it's more work. It's more difficult. Sometimes you may not be able to make it run faster without making serious changes to your system, and that's where costs start to get there. And then just changing platforms. I don't think I can work on this platform. I'm going to change to vendor Y instead of vendor X, or I'm going to change to the cloud instead of my local database. These are more complicated changes. I mean, they're not excruciatingly complicated, but they are. When you change the paradigm, it's more complicated to get there. All right. So performance is a major concern. It absolutely not producing results fast enough costs money. And that right there is the most important thing. And it all starts with proper design. I've harped on things like normalization. I'm getting the next chat will be on first, second, and third normal form. We talk getting to what is thought of as one of the most important normal forms. Although there's more normal forms we need to talk about in the slightly near term that are important to your design as well. But just getting this thing into a form that matches the relational engine is going to help you with performance, depending on how complicated your designs are. And some designs are more complicated than you can deal with easily. The problem with this is that usually people who are building databases don't really understand what proper design is, and then we don't test our software at scale until it's too late. You don't pretend like you have 10,000 customers. You only tested like 10. And the difference between 10 people hitting your database simultaneously and 10,000 is not just, you know, 2 orders of magnitude, it's many orders of magnitude greater. And then, fixing that bad design is right it's all over the place, right? It's a very complicated, very costly operation. So balance it. Fast enough must be still meet the correctness goal. Correctness. That's my thing right there, right? And it's not worth it at all. It's not worth it at all to make your database less reliable to go a little faster. Just like the car analogy that we started with. It's great to have a car that works every time you get into it. And if you can drive it faster, but it's not as reliable, you get to that same exact scenario. All right. So not one bit. All right. So I hope this was enlightening, or at least put a little light bulb over your head. I should add a light bulb to my head there. Because we're getting into topics that are I mean, it's still soft. It's still a very soft topic, but it's really kind of important to understand that building software is more about getting what the customer wants and getting it done in a reasonable way than it is, coming up with the latest techniques and using the coolest software and making the prettiest interface. It's all about getting the right answers at the right time in the right way. All right, I'll see you next time. Bye bye.